I'd like to welcome everyone to our webinar together with our partner for Microsoft Security. We are going to be diving into API security today and what it means to have a holistic API security testing strategy with a CNAPP in place. So with that, let's introduce our speakers for today. So we have two people that are going to be joining us today. On the left, we have Gadi, depending on where you're seeing him on the screen, and on the right, we have Haris. So Gadi is CEO and co-founder from Bright. He has a long runway within the cybersecurity space. So he's bringing in experience not only from what we're doing at Bright today in terms of what it means to be developing a dev-centric DAST, but he's also basing this on things that he's seen in previous companies throughout the field. Haris is joining us as product manager from the Microsoft Defender from Cloud team. He is very focused in API and spearheaded all of the API components that exist in Microsoft Defender for Cloud today. And he also has a vast amount of experience within the cybersecurity field. So this is going to be an interesting session here because both of them have very different and diverse experiences within the field. So I'm looking forward to hearing what they have to bring to the table. So what are we going to cover? So obviously we have to start this kind of a webinar with why is API security different from other things that we look at today within the application security space? And we're going to cover a few examples of where we've seen API security gone wrong and what specifically are these security testing gaps. And we'll show this through real world examples. So we're not going to be talking in the abstract here, but you'll actually see things that we've seen across customers. We're going to really dive into what is the difference here between runtime and between the software development lifecycle and why API security needs to be addressed on both ends. And we're going to show you how that comes into practice with a holistic API security testing strategy. Last but not least, all of these things are really important, but you need to be able to scale. So we're going to close this and show what it means to be enterprise ready within this entire context. And then hopefully we've been inspiring enough that you will have much questions to field to us that we will need to answer at that point. So I'm going to hand this over to Haris at this point to take us through the first step. So let's pop over to the next slide and I will give him control of the screen as well.
Great, sounds good. Thanks, Moran, for that intro, and thank you all for joining us today. So as Moran mentioned, we'll be going through the topic of API security today, and before we get into any part of the solution, we'll just start by just talking a little bit more about the area of API security, so why it's relevant and why specifically now should we care about it as well. So you'll see a couple of metrics on the slide here. I'm going to start on the very left here. The first one is that the majority of APIs, majority of web traffic nowadays is actually driven by APIs, with some studies even pointing that 83% of internet traffic is now driven by APIs. And the reason for this is that more and more so as we move away from more monolithic style application architectures to more microservice-based architectures, this has really led to this proliferation of APIs within organizations. The second piece here is that traditional API security measures are inadequate, right? So you might already have a set of tools within your existing chain that might include a web application firewall, that might include an API gateway service. And although those tools are great and do offer some level of security coverage, you'll need really a comprehensive API security solution if you want to cover the unique risks that come with APIs, like business logic abuse and broken authorization access, for example, especially in the case of these more microservice-based architectures and mobile access type of architectures. There's rarely ever just a one single point of gateway point for API entry. And in this case, it's really hard to have security just at one single gateway, and you have to think about a more holistic solution that approaches it at different angles. So we'll be kind of walking through a little bit more about that here later on as well. And the last piece here is that APIs are really the most frequent attack vector as well. And you'll also see here, we have a metric that there's been a 7 times increase in API attacks during the last 12 months. And I'll expand on this part just a little bit more here as well. So here on this screen, you're just seeing really a small subset of the types of API-related abuses that we've come across over the course of the past couple of years. And again, this is a really small subset of these attacks. There's actually public feeds that you can monitor out there that will go through and list any sort of public-related breach that's happened over the course of the past year or so, and you'll really see an uptick in the number of API-specific breaches reported in the past couple of months. But just looking at this, you're seeing a lot of a loss here in this case, right? And the reason for this is that APIs typically and by nature expose some sort of sensitive or PII data. So oftentimes when there is an API compromise, it results in some sort of sensitive data breach. So you can see some metrics here at the bottom right for the average cost for a data breach as well for an organization. And this number has also been increasing over the course of the past couple of years as well. And these kind of breaches can really impact organizations of any size in this case. And the impact can be big. So you're seeing here just metrics on the sensitive data loss in this case, but sensitive data breach when it comes to APIs can also lead to PR damage, legal fees, and revenue loss in the millions as well. So here I'll pass it on to Gadi now to go a little bit more deeper into some of these types of attacks in this case to walk through what specifically can actually go wrong when it comes to API-related breaches.
Excellent. Thanks, Haris. Appreciate that. I'm going to jump into 3 specific examples that emphasize and highlight the points that Haris mentioned. The first one is really looking at a business logic attack. So this is from experience from the field. All of these come directly from the field. And this is an organization that is a very large data provider for large enterprises. And the way they operated their APIs was they limit the requests that a customer can send, and that's how they license. And if you look at their user interface, when you try to enter the number of questions or the number of queries that you can support per month, there is a boundary control there that does not enable you to do that. If you're trying to put in a specific number in their API, there's a boundary control about a specific number. But what we noticed is that when you actually just enter a symbol, especially the infinity symbol, into their API, there was no validation around that, and you were able to run as many queries as you'd like. So this is not a standard vulnerability or a technical vulnerability the way we would look at it. It's a very unique vulnerability to APIs, where there's a breakdown in the logic, and we were able, or any of their customers were able, until this vulnerability was patched, to actually go ahead and run as many queries as they wanted without having any license to their product. A broader example or a broader view of business logic vulnerabilities, you can see a screenshot from our system that basically enables you to test for a wide set of business logic vulnerabilities. And you need to make sure that you're validating those early in the development lifecycle so they never make it into production. Another example is an LLM issue, right? Like an organization that's using a large language model and leveraging that large language model to provide data or information. We used one of the most basic ones. In this case, it's OpenAI. And you can see here that while there is validation, again, on the UI front, when you're using an API, you're able to get around some of the limitations. In this example, we actually fed the model a JSON and asked it to provide us information that is out of bounds. We should have never been able to get this information. However, because we fed it a JSON file and we gave it an information around an API, we were able to get around that limitation because the validation was not there. Very interestingly, around the LLM, in this particular case, if you ask a very roundabout question and you go into a model that's not a straight question, you're still able to get that data that the language model was not supposed to provide. And you can see a link here at the bottom to a very detailed blog post that our CTO and my co-founder Bar posted about this, explaining what LLM vulnerabilities are and how you can test for them early to make sure that they're prevented. But again, to Haris's earlier point, the API is much more exposed than the UI because the logic of testing an API needs to be built into your development lifecycle. There's a very broad set of examples. The one I just showed touches on prompt injection and insecure object handling, but there are many other LLM vulnerabilities that need to be addressed. You can see here a list of the ones that we can address and help address in our system, and how you manage those very, very effectively, both across the UI and the API. A third example comes from a different angle. We talked about technical vulnerabilities. We talked about LLM vulnerabilities and business logic vulnerabilities. In this case, it's just the ability to discover the attack surface and make sure that you're finding the places where vulnerabilities could be hiding. And that's very, very important. So we're working with a very large financial institution. And what we found out that when we were doing the tests based on the credentials that they gave us as part of the onboarding, and we'll talk about onboarding at scale at the end of this presentation, we noticed that a very small percent of the attack surface was actually being identified. And the reason for that was that they had an unauthentication button as part of their process, which means that the first scan that you did was authenticated, and then scans that were subsequent were not authenticated, so you weren't getting access to the entire attack surface. And that's a very, very common mistake and very, very common error in running application and API security scans, where if you're not identifying those logout indicators as part of your APIs, you will lose a large percent of your attack surface. So the importance there was to make sure that you have a very robust authentication mechanism for the APIs, for the UI as well, but in this particular case for the APIs, to make sure that not only are you doing the initial authentication, then you also have the ability to do re-authentication whenever you're logged out, make sure that cookies don't expire and things like that, so you're continuously providing full scans throughout. So those were just a few examples of how API security could go wrong, or API testing could go wrong in a number of different ways. Obviously, there are many, many other examples that we can dive into, but we wanted to give you real life flavor on some of the things. And with that, I'll turn it back over to Haris.
Great, thanks, Gadi. And then, yeah, there we go. So thanks, Gadi, for kind of a deep dive into the different types of API attacks in that case. So the next part I'll be walking through is now what you should really be thinking about when you're building your first ever API security strategy within your organization. So we've distilled this into 3 different pillars here. The first of which is really API risk surface hardening. So this will include needing API security specific insights and hardening that go full lifecycle. So from early stages of development all the way to runtime and production. Next is a defense in depth approach. So the main rationale for this is security is really only as good as its weakest link, right? So let's say, for example, a threat actor was able to bypass all of your proactive security controls that you've enabled for your APIs. You still need the ability to actually go and track that threat actor in their steps and then take the necessary steps to investigate any potential impact, notify your SOC teams to go and block any potential additional abuse in that case as well. So this is where a defense in depth approach comes into play, with needing both posture management as well as runtime security threat detection coverage as well. And then the last piece here is really the tie back to the broader cloud security context. As we all know, when security is handled in silos, you end up with kind of less than ideal security outcomes in this case, right? With too many tools, no single pane glass of view, it makes it very difficult for organizations to really manage security at scale. At the end of the day, APIs are just one part of your cloud application. So when you're thinking about API security, it should be in that broader cloud security context as well. So one of the ideas here is you should be able to correlate any security signals and risks across the connected resources in this case as well. So if your API is connected to a backend compute workload, which is connected to a backend storage, the ability to kind of create a map and connection between all of those different types of resources is vital to have the right ability to do risk prioritization, for example, in this case. So there's just some background into what you need to start thinking about when it comes to an API security strategy. The next part I'll walk through is now a little bit of an intro into Defender for Cloud. So I'll be walking through specifically what solution we provide for this here at Microsoft. Gadi or Moran, would you be able to, oh, there we go, perfect, sounds good. So here we're basically seeing just an overview of Defender for Cloud. I'll walk through this first, then I'll go through specifically the API security elements that come into play with Defender for Cloud. So just a quick intro into Defender for Cloud. Microsoft Defender for Cloud is what we call our Cloud Native Application Protection Platform, or CNAPP platform. And we really break the value across these 3 distinct pillars that you're seeing here. The first of which is really enabling secure development. So you can think of this as an element of posture management in this case, but really in the shift left cycle in this case. So before the application has even been pushed to runtime or production, can we actually embed security, scanning, and hardening at the layer of CI/CD in this case? So that's really the goal of secure development, and this will be one of the main focuses for this webinar as well. We'll be walking through specifically how we partner with Bright Security to help enable this on the API security testing side. Next, we have security posture management as well, the top layer that you're seeing here for continuously reducing risk. This is more so focused on the runtime security side. So as you've actually deployed resources within the cloud, can we proactively monitor and ensure that they're abiding by security best practices in this case as well? And then the last part is for CWP, or Cloud Workload Protection. Again, this is now your reactive security. So the goal is really to remediate threats as fast as possible. So as exploits come up in the cloud, so as a threat actor is exploiting any one of your cloud resources, the idea here is that we would have the right security monitoring and alerting in place for you to go and alert your SOC teams to go and investigate the impact. And just one last piece on here as well. Defender for Cloud is a multi-cloud solution, a multi-platform solution as well. So we have coverage for AWS, GCP, along with multi-pipeline support for GitHub, GitLab, and Azure DevOps as well. So now I'll walk a little bit more into detail for our approach to API security. So you're seeing here just 4 distinct pillars in this case. The first pillar is really proactively testing and fixing API vulnerabilities within your DevSecOps pipeline. And that's what we'll be focusing most of today on, is really how can we bring a proactive approach to API security. We'll go into depth for this, as really there's a full set of vulnerabilities that can really only be assessed via proactive testing in this case. Then we'll get to classifying API security posture and protecting sensitive data exposure. The next 3 pillars are really part of our runtime security solution that we have at Defender for Cloud called Defender for API. So I'll walk through in a little bit more detail all of these next 3 pillars in the next couple of slides here. So let me just go through that here. The first part of this is really classifying and understanding the security posture of your APIs. Essentially what we bring here is a unified inventory. So for any APIs that you have published within Azure API Management, Defender for APIs can provide security for those APIs, starting with visibility. So you'll see here just a screenshot of what that looks like. You can get unified visibility of all of your APIs across all of your API management resources. In addition to just an inventory, you also need insights to make that actionable as well. So you can see a full suite of security insights in this case. For example, you can identify any externally exposed endpoints, any dormant or unused endpoints, or APIs that might be lacking authentication in this case as well. And then one of the bigger insights that we bring in this case as well is to identify any APIs that might be exposing any sensitive or PII data. We saw earlier on an example of how important protecting sensitive data is for APIs, and that's one of the leading causes for data breaches in this case. So security really starts with visibility in this case. So what we can do here is we can scan all of your APIs, your API requests and response bodies, and classify any sensitive or PII data that might come across for any of those. So that's really on the posture side. Next, we get to actually hardening your API configurations and prioritizing for risk remediation. So the last thing that we want to do is give a full suite of 1,000 different security recommendations or insights to customers. That's really difficult to action on. So instead, the goal is really to prioritize risk using different vectors in this case. So for example, if we see that we have a couple of API security misconfigurations, but a few of those misconfigurations have to do with high-risk APIs, like those exposing sensitive data or those that are internet exposed, we can go and bring in that risk prioritization for you as well within Defender for Cloud in the context of what we typically call our Cloud Security Explorer or attack path analysis as well. And then the last piece here is really to monitor and protect your APIs against attacks in runtime. So we have full coverage against the top OWASP API related risks in this case when it comes to threat detection coverage. And we have a full suite of both machine learning based detection. So the idea here is for a lot of API related breaches, it's not just a simple rule based alert that will work in this case. You need to actually have the business context for that API and understand what is a normal behavior and then use it to detect any deviations or anomalies that might occur. So that's really the goal with some of the machine learning based anomaly detections that we have in this case. And then this has full integration with popular SIEM solutions like Microsoft Sentinel as well to enable your SOC teams to go and investigate the alerts that arise in their own tool suite instead of having to go to Defender for Cloud, for example, as well. So there is kind of an overview of the runtime security coverage that we provide as part of Defender for APIs. And the next piece I'll walk through is how this actually ties better together with Bright Security's offering as well. So in this case, you can see, for example, really the full lifecycle approach that we're taking for API security. On the right-hand side, we come in with Defender for Cloud and Defender for APIs, which offers this full suite of runtime security protections like what I just walked through here. And then I'll let Gadi actually speak a little bit more in detail for these dev lifecycle protections in the next slides, which basically enables this full lifecycle approach. So now you have security at every stage of development. So as the developers are actually writing the code within their IDE environments, pushing that code within their CI/CD pipelines, and once that code actually makes it into deployments within cloud resources as well, they're protected every step of the way. So with that, Gadi, feel free to take over to talk a little bit more in detail about Bright Security.
Perfect. Thank you, Haris. Now that we have a better understanding of the entire posture and the view of what the end result is, let's take a step back and understand how we actually got here and what we needed to build in order to be able to provide that comprehensive view within Defender for Cloud, and how we were able to find the vulnerabilities early and present them to the team in an effective way. So in order to do that effectively and be able to find these vulnerabilities, you need to be able to deploy and have a solution that has the right building blocks to deploy scans early in the development lifecycle. In order to do that, you need to have a number of components. One is really be able to run these interactions or to run these scans interactively throughout the software development lifecycle. That means that you might start in the IDE, and we'll look at this in more detail in the next slide, move on to the unit testing phase, move on to the CI phase, pre-production and production. So you get full visibility from code to cloud. But in order to do that effectively, when we're talking about large organizations that have thousands of developers or tens of AppSec people that need to be able to do this effectively, you can't just rely on manual processes. Everything has to be automated in order to be able to upload the correct schema in an automated way, to do the crawling of the target in an automated way, to run authentication in an automated way, to identify when there's failures in the process in an automated way, to have the APIs to integrate and provide the data into other solutions like Defender for Cloud in an automated way. So that automation component is very, very important, because if you don't have that, you're falling back to manual processes that will result in the inability to scale and find vulnerabilities early. Now, one other key metric for the automation is that integration. We'll talk about that in more detail when we talk about the enterprise deployment, but the ability to integrate with IDEs and unit testing tools and CI tools and reporting tools and ticketing systems is very, very important. And that all needs to be seamless through your APIs so the data flows correctly. Okay, so we're looking at automation integration in order to enable the iterative scanning. However, there are other components for those of us who either were or know developers. We know that unless the solution runs seamlessly for them in their environment, they will not use it and they will not leverage it. And in order for that to happen, first of all, you have to have very low false positives rate. If the developer gets notifications about vulnerabilities and 50, 60, 70% of those vulnerabilities are false positives, they will not take action. They will stop using the solution and will not leverage it to find vulnerabilities early anymore. So you have to have very low false positives. The next thing you have to have, and that's the point at the top here, is proof of vulnerability. And developers are not security experts. If you don't provide them the proof of vulnerability and explain to them, look, this is a real vulnerability that exists in your production environment, and this is what it looks like. This is how it manifests. If it's a SQL injection, you give them the headers of the table. If it's an XSS, you give them a screenshot of the XSS and many other such proofs of vulnerability. They will not know how to take action because they're not security experts. They haven't been trained on this. Once you give them that proof of vulnerability, then they can take action in a confident way. And last but not least, you need to help them understand how to remediate this. So you need to give them remediation guidelines, or in the case where we talk about even a broader integration and our broader partnership with Microsoft, we start looking at tools like GitHub Copilot. It's not just remediation guidelines, but actually automate the remediation and give the fixed code as well. So if you can do all of those components, you will have the building blocks of a solution that can be adopted early in the development lifecycle, run throughout the software development lifecycle, and help you find the vulnerabilities as early as possible and remediate them as early as possible. Because finding a vulnerability in the IDE or unit testing and remediating it is 60 times faster than finding that vulnerability and remediating it in production. And that's a huge impact on your organization if you're able to do that. What does this actually look like when, if my clicker worked? There it is. Okay. What does this actually look like when you deploy a solution like this in the software development lifecycle? It's really a buffet menu. Each user in the organization, depending on where they sit in the organization, can leverage the solution in the optimal way to provide a full comprehensive picture. So you still want the application security team to manage the governance and be able to define what needs to be scanned, how often does it need to be scanned, where does it need to be scanned, how deep do we need to scan at every stage, etc. But then you want to distribute the work between many other organizations in the team. For example, right here on the top left, you can see that we want the developers to have an integration into the IDE or into the unit testing phase and make sure that they can run scans in a seamless way at that point. Right? The next stage is really integrating into the CI and making sure that we can run scans that are a bit broader, no longer scans that take 30, 45, 60 seconds. Now these are scans that will take 15 minutes, and we're looking at more of the integration testing and finding vulnerabilities that will manifest at that point, still in most cases done by developers. But then you want to build on that, and you want to leverage your QA engineers and your QA team and turn them into security engineers as well, and have them run these automated tests as part of the Selenium, the scripts that they're running, or components like that. And in each of these stages, you're leveraging the tools that the team is already using in order to optimize the scans. So in the QA phase, they're already using Selenium. Great, take those Selenium scripts and run security tests on top of them. You're already running unit tests. Great, take those unit tests and augment them with security unit tests. You're already running development in the IDE. Excellent. Take that IDE and add security tests at that point, and I'll actually show screenshots for that in a second, what that looks like. And then very, very importantly, because as Haris said in the first slide, most applications today are cloud native. Most applications are predominantly built based on APIs, etc. Make sure that you're also testing in a pre-production or even in a production environment, but make sure that all of those reports flow correctly and flow effectively into that bigger view and bigger vision for the organization so the correct action can be taken. If you're doing all this, and if it's all done in an automated way, then you're really, A, increasing your security posture, and B, optimizing the time that it takes for developers, for the QA team to actually find these security vulnerabilities. And instead of it being perceived as, oh, you're asking me to do more, you're going to end up saving them very significant time on not having to chase false positives, not having to remediate things in production or as many things in production, and that will optimize the time they are spending. So now that we understand that breadth, all right, let's look at a different type of breadth, and this is very, very important. If you're trying to provide an enterprise solution that is not only automated and integrated, but also finds everything that is needed, you need to have very, very broad coverage on different types of vulnerabilities. And that starts with, I'm giving the examples of OWASP here and three different flavors of OWASP vulnerabilities, but we have the OWASP top 10, the OWASP API top 10, and the OWASP LLM top 10, which we talked about earlier. You need to make sure that you have a broad coverage of these and many, many other vulnerabilities when you're testing, because if you're not looking at all these various or all these different types of vulnerabilities, you are going to be exposed to something, and you need to make sure that you're testing for all the different types of vulnerabilities. Now, that doesn't mean that you're testing for all these vulnerabilities at every stage in the development lifecycle. As an example, some of these vulnerabilities, right, the LLM vulnerabilities, for example, will only appear in a pre-production environment. So testing for them earlier doesn't make sense. You need to have a solution that understands the technology that's deployed and what vulnerabilities can happen at what stage in the development lifecycle, so those vulnerabilities are tested. And that's very, very important to understand. Again, going back to our integration with Copilot for that AI generated code, we can actually talk to GitHub Copilot, understand what is deployed in that code, and automatically generate relevant unit tests for the developers. So you can even take that one step further, but in any case, you need to understand which of this very broad set of more than 10,000 payloads that we can invoke needs to be run at what step in the software development lifecycle in order to find the vulnerabilities as early as possible. Now, how does this actually look in the IDE for those developers? Because we get that question continuously of, well, you're talking about DAS. How does that actually work in the IDE? Isn't the IDE just code? And no, when you're actually in the IDE, you can see on the right-hand side now, this is compiled code, right? This is committed code that we have committed. Now, it's not the full-blown application yet. It's just a few entry points, a few parameters that have been committed. And as part of that, you can use your local host, right? And make sure that on the left-hand side, clicking is, there it is. Okay, on the left-hand side, you can enter the target of the local host and identify what do I actually want to scan. By the way, very important thing that I didn't mention earlier, we talked about mapping the target and then scanning the target. Those are two distinct activities. In this particular case, when we're running things in the IDE, we can definitely run the mapping part and finding all the entry points and finding all the parameters in this target before we run the scanning. That way, we're not delaying the developer and when they actually want to run the scans and find the vulnerabilities, because we've already mapped the targets and we already know what the target is. So you have the ability to, on one hand, map the target and then say, what are the targets that I want to scan? And on the other hand, then define what are the vulnerabilities that I want to scan for. And you can see that in this particular case, the system is automatically recommending what tests I should run based on the understanding of what is the actual content of the software that we're developing. So in the interest of time, I didn't go into a full-blown demo of how this looks in the IDE. Obviously, happy to engage and show a much more full-blown demo of this, but it's important to understand that you can already run DAS scans as part of the IDE, and that's a big change because we're not just giving the developer, oh, these are potential vulnerabilities. We're giving them both the vulnerabilities and the proof of vulnerability so they can take action based on that information. So important to understand that that can be run. The last point I will touch on is going back to that integration component and what this looks like. And you can see that the integrations or basically integration hub touches on many different areas. There's CI integrations, there's ticketing integrations, there's IDE integrations to make sure that it's very easy for the organization to deploy the solution. So on one hand, there's a plugin to VS Code or IntelliJ that the developers can just download and leverage. On the other hand, if you're using GitHub or Azure or other solutions, you can see that there's integration into the CI, so you can just trigger the scans as part of the CI, or integrations into the reporting and ticketing solutions, so you can just provide all the data into those environments in a seamless manner. So just another component around the integration to make sure that it's easy. With that, we dove into a lot of detail. Hand it over to Haris to actually show what the reporting side looks like in action.
Great, sounds good. Thanks, Gadi. So let's go ahead and start and see this actually in action now as well. So I'm going to start just here in GitHub just to show you kind of how to actually get set up with Bright Security in this case. We'll do the same for ADO, and then we'll actually see how this actually looks within Defender for Cloud as well to really enable centralized visibility then for your security team. So quickly, just within a GitHub repo in this case, I have here just a sample repo that has an API application that has some common security vulnerabilities in this case. The Bright Security team has actually published this repo as well. So if you're interested in learning more just about generic API-related vulnerabilities within code, this is a really great benchmark to kind of take a look at here as well. But with that, let's go into the Actions tab in GitHub. And here I'm going to start a new workflow. In this case, I'm going to search for Bright Security's a workflow in this case, which is called here as NeuroLegion, and I can go and configure that workflow in this case. And just within, I just have to fill in a few details here on how the API works in this case, loading up the application, and of course, initiating the scan. I've already done that piece here, so I already have a few workflows already that exist within this repository. I'll just skip to one of those here. And here you can see that we run this scan. In this case, we run this every single time on kind of a manual run for this particular workflow, but you can set this to be an automated cron job or anytime there's been a push to main branch, pretty much to get as a part of an automated process within your developer workflow. So in this case, this will run the Bright Security scan. So it will scan this application for any sort of API and application security related risks. And they will also upload these results to GitHub code scanning as well. So we've already run this scan before. If I go to the Actions tab here, you can see that we did run this scan earlier. You can see that the issues were reported in this case. So as a developer actually ran this workflow, you can see that Bright Security in this case did find a critical issue in this case. And we can actually go and see the details for that critical issue directly within GitHub as well. So if I just go to the Security tab here under code scanning, I can actually see specifically what Bright Security found in this case. So I can see that this checks if the application incorrectly evaluates a user controllable data. There's a lot more details on this as well. You can click here to go to specifically Bright Security's page where they'll go in detail for specifically what this insight was, along with a remediation information here as well. So this was all within the developer workflow for GitHub. It's the same exact case for Azure DevOps as well. In this case, I have a sample repository, and here I have an Azure Pipelines. And in this case, you can see I'm running the same exact scan in this case, this Bright Security scan, and it will do the same exact thing. I will push these results. In this case, I will publish it as a serif. And this is basically all we need in Defender for Cloud to take these results in and showcase for centralized security teams. So again, everything I've showcased so far has just been within the developer workflow within both GitHub and Azure DevOps. So now let's go to the security team. So security teams most likely won't really have access to source code repositories. They won't have that level of visibility, but it's super important from a central security standpoint to know if somebody's pushing any insecure code into production. So let's go ahead and see how this looks within Defender for Cloud. Here, I'm going to navigate to the Defender for Cloud portal. And here we're going to go into the Recommendations tab. So within Recommendations, I'm going to search here for API security testing. And you can see that that same Azure DevOps repository that I was showcasing earlier, is found here as well. So if I click into this, you can now see that Azure DevOps repository should have API security testing findings resolved. And you can actually see details for this as well. So I can go into findings and I can see all of the security findings that was found from that Bright Security test in this case. So I can click on any of these. I can go back to that specific ADO repository if I would like to as well. You can see this was found from that NeuroLegion scan that was run. And you can see all the details for this as well. So why you should care as a central security team as well for this. So that level of visibility is now available within Defender for Cloud in the same purview as all of your other cloud security related risks across Defender for Cloud. So in the general recommendations tab here. In addition to that, this also plays in with our cloud security experience within Defender for Cloud. So this kind of goes back to the point I was mentioning earlier about the importance of risk prioritization. It's great to see siloed recommendations to some degree. However, to really take action from a central security standpoint, you need to have an understanding of which risks are more important than others. So that's really one of the goals of the Cloud Security Explorer in this case, is where you can actually craft queries to see what's most sensitive and most important for your organization. So let's go and see and kind of take that into action in this case with the Bright Security scan. So in this case, let's go to DevOps in this case. And let's search for any code repositories in this case that have that specific recommendation. So by title, so I want to find any code repositories that have any API security testing findings. So I'll search for both my Azure DevOps repositories and my GitHub repositories in this case. We only really care if this recommendation is unhealthy, which means that there are actual findings that need to be taken care of. So let's put the status as unhealthy in this case. And just to make this more interesting, let's only care about code repositories in this case that allow for public access. So not only do these code repositories have security issues, we actually have that as an open repository, so anybody can access it. And of course, that's just one specific insight. There's many other insights that we could look for here as well. So if I just go and hit search here, this will just take a second, and this query will return back all of the found repositories that meet this criteria in this case. So in this case, let's see, for example, we have here this bad hacker repository, and you can see that this specific repository has API security testing findings that need to be resolved and also allows for public access. And then similarly, I can go and get a link to go to that ADO repository directly as well. So this kind of just showcases how this all comes into play with a broader CNAPP solution, where you can actually go and correlate different security risks together to aid in risk prioritization in this case. So there was a demo that I wanted to showcase, and I'll pass it back now to Gadi to take it over for kind of closing us out here.
Excellent. Thanks, Haris. Very, very cool. Every time cool to see that. Now that we've talked about a lot of the details and looked at the deployment from both the right-hand side and how this looks on reporting and making sure that you have prioritization and can take action, and how it looks on the left-hand side to make sure that you can actually find the vulnerabilities, etc., it's very important to understand how this can be done at scale. If we take a step back and think 10 years ago, 5 years ago, most application and API security postures and most programs really focused on a small set of people, just on the AppSec team, which could master all the process, but would have to run everything manually. Now that we broaden the vision and we have a very large amount of people, including developers, QA people, etc., leveraging the solution, you need to make sure that you can do the deployment at scale, because now you're looking at thousands of people with thousands of targets instead of just a few people with a few targets. In order to achieve that, we look at the deployment in two parts. One is the onboarding component. How do you make sure that you're onboarding everything effectively? And the second is the ongoing. How do you make sure that running the solution in an ongoing basis works very, very effectively? Because if you can't achieve both, you'll either never get started, or at some point things will break and you will not be able to maintain the efficacy of the program. When we look at onboarding, there are a number of components. First of all, you need to know what are the targets, right? You need to be able to onboard and import those targets into the system, whether they are APIs or if they are web applications. And in many of the cases, there are thousands of different targets you need to be able to onboard and import into the system. So unless you have automation mechanisms to be able to parse those targets and bring them in, you are going to have a very hard time doing all of that manually. The next one, and we talked about this in one of the case studies for the bank, for the large North American bank, if you can't set the correct authentications, you are never going to discover a broad attack surface. If you're not finding the entire attack surface, you are not going to find the vulnerabilities that could be lurking in different places in that attack surface. So the ability to automatically set a broad set of authentications and make sure that all your applications and APIs are authenticated is very, very important. The next one is really in the discovery part. So the ability to discover all the entry points and all the parameters, whether again it's an API or a web application, is critical. And in order to do that effectively, you need to have the ability to upload schemas, or the ability to crawl targets, or the ability to upload HAR files or Selenium scripts, as we mentioned earlier, the broad set of ways to ingest the target so you can parse them correctly and find all the places where vulnerabilities could be lurking, and automate the scan components, whether it's automatically in the ID or automatically when you run unit testing, or as Haris just showed, in that CI flow. So whenever you reach a specific step in the CI flow, a scan is triggered and is run, and then you can't continue to other steps in the CI unless boundary conditions are met. So if you have critical vulnerabilities, you might decide I can't continue beyond them until they're fixed. Or if you have multiple medium vulnerabilities, you may decide I can't continue in the CI until they are fixed. You have the flexibility to do that, but all of that automation needs to be set up. Okay? And then very, very important, in order for the AppSec team and for the rest of the organization to be able to report on this effectively and correctly, you need to automate the ticketing and the reporting components, whether you're doing that directly in our solution or much more broadly within solutions like Defender for Cloud, or we talked about GitHub Advanced Security and other solutions like that. Once you've set all of that up and you have everything working correctly, as the initial phase, now you're looking at ongoing automation. And we're starting to touch on things like pre-authentication. So a cookie expired, or somebody changed credentials, or things like that. How do you get the right notifications and the right workflows in order to automatically re-authenticate and make sure that you're not missing part of the attack surface, like we've seen with many organizations. And basically they think they're doing full scans, but they're doing very partial scans. The ability to separate discovery from scanning, I mentioned that as an important component when we look at the deployment for developers, but it's important throughout the software development lifecycle. If you can pre-map and pre-discover, all your scanning will happen much faster, and you'll be able to fit it into different windows that you want to fit it into. If you were saying, I do a release every Thursday night or every second Thursday, and I have a window of 4 hours to run the scans, and I want very comprehensive scans, that can only happen if you're pre-discovering the targets and making sure that you're just running the scans during that time. So the long-term viability of a program depends on capabilities like that. Okay? When something goes wrong, right, if you are losing credentials or anything like that, how do you get the right notification so you can take action? Or even better, and that's not always possible, but sometimes it is, how do you automatically have the system resolve those issues when it encounters them? Okay? Auto-scaling the infrastructure. We have customers that started with 500, 600, 700 targets and now are running scans on thousands of targets. How do you scale the infrastructure to make sure, if you're doing this on Azure or if you're doing this on AWS, make sure that the infrastructure scales to meet the demands of the organization? And very important and very top of mind these days, how do you scan developer-generated code, but also AI-generated code? Because more and more organizations are starting to leverage tools like GitHub Copilot and generate AI code with AI, and you need to make sure that that code is addressed in a similar manner to developer-generated code, but it has many different permutations and many different needs, and that means that you have to be able to accommodate and address both of them. So when we look at scale, both the onboarding piece and the ongoing piece have to be addressed and have to be built into the solution to do this very, very effectively. With that, I'll wrap up my piece. I'll hand it back over to Moan to take us home.
Cool. So we're almost to the top of our hour here. So we're going to wrap this up quickly with the takeaways that you should have already figured out on your own, but we're going to wrap it up again just in case, and go to some of the questions that we have. So the key narrative here, if it was not clear, is holistic. So how do you do things on both ends? How do you bring things together, both in terms of visibility, both in terms of the type of test, the type of environment, whether you're just starting out or you're just ending? So really the starting point for everything, especially if we're looking at modern organizations and enterprise, is cloud. So we need to be testing pre-deployment and we need to be managing our posture post-deployment. You can't start just on one end and ignore the other side. They are so wrapped into each other and integrated, especially in this continuous integration, continuous deployment world, You can't just do one thing and not do the other, because this isn't a water for world anymore. The other thing is that you need to be testing for more than APIs. Bright customers that are on the webinar today can definitely attest to this, that what is a vulnerability that is just web, or is just API, or is just a business logic? Depending on the context, it could be all three of them, or even also an LLM vulnerability. So you cannot look at something in a very, very specific, narrow viewpoint. You have to be looking at it in the broader context, and you have to be testing for everything. The other thing you need to be looking at here is the integration visibility. And we saw this when we were looking at Microsoft Defender. You know, the added value here of just being able to see everything under one roof, and to have that clear visibility, what is happening and where you need to be addressing and focusing your efforts, is critical. And it's especially critical when you're looking at how many tools developers and AppSets have within their tool set today. So you want to be able to create this integration for visibility. And the last thing, and I think this is something that is many times taken for granted, but more important than people realize, is that you have to be looking at scale. This feature fixation sometimes that we see when people are just getting started on their API security testing journey, or looking at what a CNAPP is and what they need to be doing moving forward. Yes, look at the features, make sure that it addresses everything that you need to do, but make sure that when you're ready to run, that whatever you've chosen can support the scale and support the velocity that you need to move at. And that velocity really is like the segue into code gen. We're looking at a world today where 40% of the code is already being generated by code gen tools. And by default, if more code is being generated by AI, at some point we're going to have a lot more code. So we need to make sure that we know how to test this, because when AI is writing this code for us, sometimes the developer is going to come in and he's going to say, well, I'm not sure exactly what was written here. So the context doesn't exist, even when you're pulling the PR back up and looking at things and trying to debug it. So we need to make sure that we're taking into account all of these next generation tools that we're now pulling into our software development life cycles in order to accelerate velocity, and make sure that we know how to test them as well. So that wraps up everything that we've been talking about today. We do have some questions. I'm not sure we're going to be able to get through everything. So in the meantime, while I pull up the questions here and I start shooting them to Haris and to Gadi, feel free to snap a picture of the QR code here. It will take you to a landing page if you want to talk to the Defender for Cloud team, if you want to talk to the Bright team, if you want to talk to both of us together. We're happy. Even if it's just questions, feel free to put your questions in there and we'll get back to you. And if you feel like you want to reach out to the people that have been sharing their experience with us for the entirety of this webinar, here are their contact details, and we will also share this in the follow-up email. So the first question that we had here, and I apologize if this throws out of the screen, because sometimes this is a bit annoying. Let's see if it pops up the QA here. No, so I'm going to stop sharing in order for me to read the questions, because obviously it will not let me do it otherwise. So the first question that we have here is, does organization size matter for CNAPP implementation benefits? Is it more sensible for enterprises or for SMBs? Okay, and I see that Gadi has already raised his hand here and he wants to be answering this. This is both in terms of the implementation complexity and the affordability.
I think I'll actually let Haris address his take on it, and then because he's the CNAPP expert, and then I'll talk about it as well.
Yeah, definitely. That'll be great. It'll be great to get the perspective from more of an application and API testing perspective as well. But at least for the question, there's a couple of angles here. One, is it more sensible for enterprises or SMBs to adopt a CNAPP solution? From a security risk perspective, it's the same risk, right? So when it comes to a cloud application, whether you're an SMB or an enterprise, you're still deploying cloud applications in this case. So you're still deploying APIs, VMs, containers, whatever that might be. And the same security risk is apparent across the board in that case. So really, it's less about enterprise versus SMB, more about where you are with your adoption of cloud in general. The second part, though, goes into detail about when it comes to implementation complexity and affordability. So I'll start with the first one when it comes to implementation complexity. This is a really important part when it comes to CNAPPs. Really, the main focus area is how can you really enable this at scale for larger enterprises, right? If you have hundreds of thousands of organizations or hundreds of thousands of teams, hundreds of thousands of applications within your organization, how can you make sure that you have security, and how can you make sure you have security from day one? So that's really where it's such an importance to have security that starts automated, so you can enable this with just a few clicks of a button and have security across your entire organization. But even beyond that, right, even after just enabling a tool, there's still parts about fine-tuning tools and making sure that you don't have noise, because sometimes what happens is you'll have security tools, but there's too much noise that it reduces any actionability, and that tool is effectively not as useful within your organization, right? So those are all really important things to consider, and it doesn't matter as much when it comes to enterprise or SMB. The biggest difference I typically see between an enterprise or SMB, both will use CNAPP solutions. When it comes to enterprises, they may not use some of the user experiences or dashboards directly given by a CNAPP provider. Rather, they will create their own custom workflow to integrate with the other various tools that they have within their organization. Whereas SMBs might use a native workflows and tools directly available within the CNAPP solution itself. So using the Defender for Cloud portal and using that as kind of a comprehensive suite, since you might have a fewer amount of cloud applications in general. So that's on the implementation complexity. And then affordability, this typically just scales with the adoption of the cloud that you have. So you can be an SMB with hundreds of APIs in that case, or hundreds of applications, which could be even more expensive than an enterprise that has less adoption of the cloud, for example. But typically a CNAPP solution should scale typically proportionally with the types of applications that you have in the cloud. And that's really where the affordability part comes into play. But with that, I'll let Gadi speak to any additional points that you'd like to add on to that question as well.
No, I think that was very comprehensive. The one thing I would say is we see the world less divided into SMBs and enterprises, and more divided into good enough is good enough and good enough is not good enough. And those organizations that have higher risk, like financial institutions, like tech companies, organizations like that, typically good enough will not be good enough. And that means that they won't go for open source tools or for free tools. They will go for the real enterprise deployed solutions like Microsoft, like Bright, that will provide that scale and that confidence. Whereas organizations that don't have the ability to spend or the desire to spend and the risk is lower might go for other solutions. So that's more of the dichotomy that we see.
Cool. So we just reached the top of the hour. I was considering pushing in one additional question, but we will get all the questions answered and send them out during the follow-up. So thank you to everyone that actually stayed to the end, which is always a wonderful surprise to see after 60 minutes of everyone talking. We hope you found this insightful. And if you have any questions that pop up later on, you know what our contact details are. Feel free to reach out and we will be happy to answer them and get you started, hopefully, on a correct strategy for API security testing moving forward. So thank you to our speakers.
Thanks, Haris.
We shall see everyone again.
Thanks, everyone.
Bye.
Thanks, everybody. Bye-bye.